Okay, so we're starting differentiation, just a little recap from year 12. So how do we do differentiation? What's the answer to the first one? So dy by dx, differentiate 15x to the power of 4 plus 3 over 6, which is actually a half, minus 7x to the power of 6. Cool, everyone happy with that? We'll change that round to a half. Happy? Alright, next one then. What's my notation? If that's dy by x, this one here is f dash x, good. That becomes 4x, is it? That next one becomes positive 9.
Oh, 9.
Negative 3 times negative 3, positive 9. X to the power of negative 4. Everyone understand why it's negative 4? Because you take one off the power, yeah? Okay, so the next one will become, that's going to be 14 x to the power of 6 all over 5. Happy with that one? So a little recap. So now what's the grading of the graph at x equals 3? So how do you do those ones? So you do exactly the same thing, don't you? So dy by dx is 10x to the power of 4 minus 8x. What happens to that 6? Disappears because when you differentiate a constant, it's... Yeah, okay. So at x equals 3, dy by dx is 10 lots of 3 to the power of 4 minus 8 lots of 3. That's 810 minus 24. So I'm going to assume what you guys are saying was that 86. You happy with that? So what is that telling me? It's very, very steep gradient. So that graph there, when x is 3, has a gradient that is ridiculously steep. Cool. The last one, again, just final turning point stuff. Well, sorry, final recap of year 12. Final turning points of that function state their nature. So what I do, differentiate fx, so f dash x is 3x squared plus 4x minus 15. Then what do I do? Why do I factorise it? Turning point, when the gradient equals 0, so therefore 3x squared plus 4x minus 15 equals 0. So then you factorise it, or you could go straight to the quadratic equation, but let's not go down there. Factorise that. 3 lots of 15 is... The 3 lots of 15 is negative 45. I hope it doesn't go on the video. You're always going to watch it for like 4 minutes. So 45, what do I do with negative 45? So the factors of negative 45 added to 4 must be 9 and negative 5, is that right? That'll be on there too. Come on. 3x squared plus 9x minus 5x minus 15 equals 0. Factorise the first two terms there. 3x into x plus 3. Want that to be exactly the same. So let's times that by negative 5, which makes it 3x minus 5 x plus 3. Who remembers that steps from last year? Who remembers doing that from last year? No one? Well, half, 4 or 5. Okay, cool. As long as you get the same answer, I suppose that's all that matters. So, not one scroll up. So x is -3 and positive what? Positive 5/3, yeah, not 5. So now last year, put it away. Last year, to do that particular question, how did you state their nature? Basically, was my question I'm trying to ask you now. How would you state the nature of those turning points there? That's for you this year. You didn't have to do it last year. So different to what you said then. Second derivative wasn't actually in the level 2 course. You didn't actually have to do that, but it is actually the easiest way of doing it. But to do that now, how would you do it? You could substitute those two back in the original equation, and one will give you a high number, one will give you a low number, and therefore one's the max, one's the minimum. The way I taught my class last year is that there is that, isn't it? That's what you did that's what you got resubbed on. How do you remember that? So there's your positive cubit, looks like that. So if you're looking at my 2x values, which is the one on the left, so that one there must be -3, yeah. That one there must be my 5/3 because the furthest one left will be the -1, the furthest one to the right will be the biggest number. So which is the minimum? Which is the maximum? So that was your level 2 stuff last year. Level 3, what we're going to do is we're going to try and prove that. And if we do that now, because it's what Sam did last year. So what Sam did was, okay, so we have fx was 3x squared plus 4x minus 15. If I differentiate that again, what does it get me? 6x plus 4. So that's the gradient function of the gradient function for the function. Sounds confusing now. Let's just ignore that then. But at x equals -3, f dash dash x will be -18 plus 4 will be -14. And x equals 5/3, f dash dash will be positive something. Okay, so all you're doing there is you differentiate again, substitute those numbers in, and if your answer is negative, it means the gradient of the gradient function is decreasing. In other words, it's getting smaller and smaller and smaller, which means it has to be a maximum. Okay, if the gradient function of the gradient is getting bigger, and the gradient's getting bigger and bigger and bigger, therefore it is a minimum. Okay, but that's level 3 stuff. We'll get onto that. That comes later on. But that's all we're going to do. State their nature. And to be honest, isn't it like if you'd spent time last year, would that be pretty easy to probably do? I mean, who did that last year? Who did that last year? Probably down to your teacher more than anything. Oh, there you go, learn coach. But yes, it wasn't part of level 2, so it used to be. I took it out. I think it should be in.